Thank you very much. Well, my name is Alex. I'm a software engineer at Devreal Data Lab, where we are building a data science platform that allows data scientists to have a system of record where they can build and execute and productionize their different models, which means in some ways that we allow data scientists to run arbitrary Python and R code on a Kubernetes cluster. So using Kubernetes to deploy things at runtime is kind of interesting, and even if it's a Scala talk, it's going to be kind of more of object-oriented and less functional Scala talk than what is happening at the functional room like during this conference. So, all right, I'm just going to start by introducing some of the base concepts for Kubernetes and talk really quickly, like just give you enough information about how networking works on Kubernetes so that we end up being able to write a pretty simple, pretty basic reverse proxy on Kubernetes. Please don't use what I'm doing in production. There are better services like Traefik and linkerd that does that in a way that is actually sound to use in production. So, all right. So first, the base concept on Kubernetes is called a pod. So basically, Kubernetes as a container orchestration system allows you to run any Docker container over a given cluster, but these containers get packaged in what is called a pod, which is kind of equivalent to having one physical machine with your Docker containers running on the same machine. You can have multiple pods running on the same Kubernetes node, but only the containers that are running inside of the same pod are guaranteed to be able to see each other as if they were running on the same machine. So you could have two pods running on the same machine, and they're not necessarily able to talk to each other as if they were running on the same machine. So to allow documentation of how to communicate with pods that are hosted on a Kubernetes network, there is this concept called a service, which basically describes a contract to communicate with these given pods. So basically, these sets of pods that respects these particular patterns exposes a web service on port 80, and from that, Kubernetes will be able to create what it's called endpoints, which are IP addresses that allows you to address each individual pod described by that given service at that given port, which kind of allows you to handle networking over that. There are different kinds of pods. For the sake of simplicity, I'm just going to mention two of them. By default, every service are cluster IPs, which means that you can't access them outside of the Kubernetes cluster. But you can also create some node port services, which exposes what is called a node port, which is a randomly assigned port. And it will be open on all Kubernetes nodes, so you can access your service from outside of Kubernetes. And that is pretty practical, but assuming that you might want to have multiple different microservices running on Kubernetes at the same time while having only one actual service serving all of your external traffic and being exposed to the outside world, you need something to describe how to access every given service based on some routing rules. And so there's this concept called some ingress resources that basically are simple descriptions of routing rules. There are different types. I'm just going to use some path-based routing for my presentation, which basically describe, on path / users, redirect all traffic to your user services, but you can also do some routing over the URL. But then that means that you need to handle DNS, and I only have 20 minutes, so I don't want to get too deep into DNS for the sake of my presentation. So that's pretty much all base Kubernetes concepts I'm going to use for the sake of my presentation. There are a lot more, but I don't think it will be really useful just to get started to write my reverse proxy. However, I think there are some parts of Kubernetes networking that needs to be addressed to understand how it all works. So considering that Kubernetes will run Docker on many different nodes that are on different physical machines, you do need to have a networking layer that will emulate having all of these pods as if pods running on the same machine are not actually running on the same machine, while all of your pods running over your cluster can be accessed to each other as if they had their own individual IP address. So it uses what we call some application networking layers like Flannel and Calico that basically handles assigning IP addresses and handling all of your networking and IP tables rules to ensure that everything remains accessible. And what this means is that each pod will have their own unique IP address. Each pod that is represented by a service will also get its own IP address to ping that particular endpoint for that service. And ultimately, if you want to get these IP addresses dynamically, well, you ultimately will need to call Kubernetes, which is really important if you're writing, let's say, a reverse proxy. If you're writing something that is more static and want to have something easier, there is this service called kubedns, which handles this abstraction. So basically what it does is that for every pod and every services that are described on your Kubernetes cluster, you will have some DNS addresses that describes how to access them. For pods, it will be its IP address, its Kubernetes namespace.cluster.local. Typically, you won't even know really what is your pod IP when you're running your application. So typically, this is where you would really want to take a look at the service, at the way to access the service, which is service name.namespace.svc cluster local. And considering that we're writing a reverse proxy, if I wanted to make things optimal, I would take a look at how to have each endpoint and how to load balance over these endpoints. I have 20 minutes in front of me, so I basically just decided to use kubedns to simplify my code base. So yeah, basically what it means to write a reverse proxy based on these simple concepts is that we will have a service running on Kubernetes exposed to a node part that will watch every updates that are done to ingress resources on Kubernetes and update its local routing rules. Everything will be wrapped in an HTTP service. I use Finch because it's a nice HTTP layer in Scala, and we're at Twitter, so I think it's nice to use something that uses Finagle in the backend. And ultimately, when we receive a request for a particular service, and there is an ingress resource that describes how to access that, we just redirect the traffic to the correct service implementation. And I'm going to give you a quick demo of how it looks like. Can you see it? All right. So just for the sake of it, I've got a Kubernetes cluster running with my reverse proxy, literally named proxy, but in the reverse order. So it is running. There's nothing else. There's no ingresses running right now. It's pretty basic. Just to give a quick demo of the code base, I'm using a library written by Fabricate, which is a Java system to interact with like Kubernetes and OpenShift clusters. There's not really any good Scala client for Kubernetes right now, so you do need to handle using a Java library. It can be impractical at times. So basically, the only thing I'm really doing to know which are the ingresses being pushed on Kubernetes right now is to set up what we call a Kubernetes watcher and to register it to the ingress resources. So basically, I have my Kubernetes client that wraps that Java client, and at line 21, I'm registering the new the watcher that I'm defining, which basically will be called every time we receive a new action over a particular Kubernetes concept. In this case, it will be ingresses. And just to keep things simple, I'm just pushing that new ingress rules, overriding previous ingress rules every time I'm receiving a new value. And basically what it means when I'm handling my routes is that if I already have an ingress, if that ingress already exists, I just override it. If that ingress doesn't exist, then I just add it to my list. And I forgot to implement delete. That's totally on me. Otherwise, I'm just keeping a list of what are my current ingresses for that version of the routes manager and what paths maps to given Kubernetes services. So basically, this means that I'm just iterating over my ingresses, extracting its different rules, taking a look at the path inside of the rule, and I'm just mapping that path to a given service. And when we're querying that, we're just mapping over the head of the path to see if we have any ingress defining how to access that given path, and then we return the right Kubernetes service. There's nothing more. It's pretty simple, and it allows us to, when we have nothing running there, when we're calling Kubernetes and the node port for my proxy, I'm getting a kube service not found for path hello, which is exactly the error that we're seeing at line 15. And this works great, except that I'm not doing anything that is actually practical right now. So for the sake of actually demoing something that is complete, I'm going to deploy a new service, which is just a simple Nginx cluster that will always return hello Scala by the bay as text. As I said, this defines a service. I even can make it not a node port just to make things more complicated for me. So yeah, it maps this service, as I was saying, will map every pod running with label hello, application hello. And I'm creating my pods through what we call a Kubernetes deployment, which ensures that there's always a certain numbers of replicas running, by default 1. And I'm defining an ingress to access that hello service that when we ping path hello, will be redirecting the traffic to the service hello service. So let's create these resources. Everything gets created. Can get my ingress rules. I've got hello ingress created. I can get my pods. I've got my reverse proxy and my deployment running. And when I run that same query, I get hello Scala by the bay. And this is why my second most complex hello world I've ever done. Yeah, that's all I had for you. Do you have any questions?
Thanks very much, Alex. Any questions?
You said this was the second most complicated hello world you ever wrote. What was the first?
I implemented a hello world using Matroiska. Recursion schemes are interesting. This is why I decided to do a talk on Kubernetes and not recursion schemes. I'm not at this point yet.
Further questions for Alex?
Oh.
Thank you so much.
No.
So yeah, fun.
Did I understand correctly that when more ingresses are created, this thing does not, the reverse proxy does not have to be restarted, it will react to the
Yeah, that's the whole point of using ingresses and watching over the values of ingress, so you don't have to restart your reverse proxy and get your running rules updated dynamically up to date. Mm-hmm. Yeah.
Cool.
Thank you so much.
All right.
Yeah.